फिर PVC, polystyrene, 3G, 4 monomer polymer में right 4 years that means 4th one. In Teflon, the monomer of the Teflon is tetrafluorethene, then 4 fluorine attached with 2 carbon. So that's the monomer, that's the polymer Teflon, tetrafluorethene, and the discrete structure of the polymer is 4 carbon. Fluorine and liquid. That's the structure of it. So basically, the weight unit is like 2 distinct carbon atoms. While for the physical property of Teflon, it has high melting point. And it is slippery to touch. Because of this characteristic, the use of the Teflon is that it is used in making of non-sticky pans. Firefighters. Teflon's melting point is about 4,000 degrees Celsius. So metals and most of the metals melting point is less than 3,000 or something. So it's the kind of plastic which melts at much higher temperature than a metal even. So because of that, it's used in the coating of the non-sticking pans, the black coating in the frying pan that we. Many students are missing classes because of walks. It's normal. So we are doing addition polymers. Teflon is the 4th one that we will be having today. Or that is, I mean, जिन लोगों ने टेबल बनाया है तो उन्होंने actually याद किया है. Recording में काफी सारे लोगों ने शेयर की है मेरे ग्रुप ऑलरेडी. शेयर तो की है लेकिन मैं फिर एक दफा देख लूंगा जो बेसिक डेट्स हैं मैं पोस्ट कर दूंगा फिर से. अब देख लें अच्छी बात है. We are actually doing polymers at the moment. Addition, condensation polymers and addition polymer. We made a table yesterday and we still have one more Teflon to add on, right? उसी headers में आप add करते Teflon. तो मैं बता रहा था कि जो non-sticking pans, frying pans we use for cooking at home, and the black coating inside that pan or the cooking utensils, that is actually Teflon plastic or Teflon brand we have by the way cooking pans. And they're famous for the fact that उसमें आप food cook करते हैं, it doesn't stick to the bottom and cooks well. So it is slippery as well. If you ever try and cook something on that, you feel like अगर आप stack fry कर रहे हैं, it doesn't stick, and you can actually easily put it away. It's a plastic, so it's not even harmful. So maybe with that, plastic होता है क्योंकि frying pans में या cooking pans में which is harmful for the health. it actually doesn't melt before 4000. और जो stove में flame होता है, जब हम जो stove use करते हैं, that temperature of that flame hardly goes above 700 degrees Celsius. So 4000 degrees Celsius step on the melting point, it doesn't go near that. Firefighters use clothing and the jackets and everything. That is made from Teflon plastic because they have to go to places where the temperature is very high. To put your normal dresses or would need to insulate the air that would melt to Teflon plastic. ये हमारा addition polymer रहेगा बेटा. तो आज हम पूरा चलेंगे. अब next side है बन जाएगी condensation polymers. Number 2 पे addition polymer first, then we directly add to the second condensation polymers. Condensation polymers में what happens is that two monomers, typically two different monomers condense together by the loss of water molecule typically. And that's why we call them condensation polymers. This definition is like polymer formed by condensation of you understand what I'm saying? What is this? Most of the language you learn by assuming this stuff. What is the name? आपकी क्लास होता स्टार्ट होती है 20 पे. बिल्कुल 320 पे और अभी 333 हो रहा है. तो उस हिसाब से मैंने कम लिखा है. Polymer, which is formed by the combination of two different monomers. That name classes में कौन आएगा पेपर देंगे क्लासेस में ऑनलाइन कोई पास पेपर के डाउट्स और उसके लिए वैसे we are here. I mean, before the exam, you could come in. Otherwise, just like if it's your maths exam 2 days after, so naturally you won't study chemistry or physics. Teachers are always around. आ सकते हैं लेकिन इस तरह से टाइम टेबल वाली क्लासेस में इस तरह से. So while water is formed as a byproduct. Addition polymers में क्या था कि same monomer, जैसे कि Teflon का monomer, एक ही monomer combined together many times and then you get the addition polymer, right? In all the addition polymers, like polyethylene, PVC, सब में same monomer repeats and no byproduct, no water is formed. But in condensation polymer, water is the byproduct. And in this process, two molecules, two organic monomers, which are typically different from each other, they combine, they condense together to make these polymers. The first example that we start with is polyester. Polyester is a polymer which is soft and silky, and that's why it is used as artificial fiber or in the garment industry. Even इसका use of physical properties start to live here sometime we get afterwards. Polyester is known to be soft and smooth and silky, and that is why it's used as an artificial yarn or fiber. the garment industry. All these sweaters, shiny dresses, quilts, pillows, all these things that we now use, they contain polyester in them. And अगर आप उसका वो tag देखें तो it says 80% polyester, 30%, 20% cotton, and all, like all the dresses that we wear now. That's hardly pure cotton or pure silk. So this polyester has actually taken a lot of space in garment industry already. So many dresses. I mean, all these dresses you're wearing even at the moment will have a lot of polyester in it. As part of these monomers, they include carboxylic acid, because the name of this polymer is a polyester. Poly means many, ester means ester, right? Many ester links, many ester bonds. So in this polymer, polyester we have many ester links, many ester functional groups will come. An ester functional group is formed when carboxylic acid reacts with alcohol. हमने थोड़ा last stage में पढ़ा है. जो monomers हैं इसके of polyester include dicarboxylic acid, dicarboxylic acid. It's like a carboxylic acid. Like it's a compound with two carboxylic acid functional groups. Now we show the dicarboxylic acid monomer typically in this form. The shaded box in the middle shows carbon atoms. Could be one carbon atom there, two, three. So हम सिर्फ functional groups को highlight करते हैं. We show carboxylic acid and it's a dicarboxylic acid. Two carboxylic groups present in it. And then it is in the form of diol. So dicarboxylic acid and diol. Diol is it's a compound which has two alcohol groups on it. OH groups. इसको भी हम इस तरह से दिखाते हैं. So dicarboxylic acid and diol. In the middle, instead of a square box, it could be a circle, it could be a blank box there. So which we also have. I'll write rather here. This CH2 group here, this box refers to CH2 group. ये मैं थोड़ी देर में बताता हूँ what does it mean. The box, in fact, is CH2 chain inside. Okay, so what we do next is show how these two monomers combine together to make the polyester polymer. Easy reaction है, आप इसको समझें, मैं बोल सकता हूँ. Okay. And just after this, you could actually write this equation. Remember, we have this carboxylic acid, COOH, in the box, COOH, dioic acid, dicarboxylic acid or dioic acid. It reacts with the diol. So the same monomers that I wrote here, I've written them in the form of reactants. We just show the reaction happening here. And the conditions required for the reaction include concentrated sulfuric acid, H2SO4 and H. Now the nickname that I'll just first explain it and draw the structure of the polymer. All right. So what we do here is I'm taking a report of that. This is the diol OH group, two alcohol group, and this is the dioic acid, two carboxylic groups. So when you get something like this and you're asked to show the product, you should understand that these two are the monomers of polyester, right? And how would you show the reaction? You just have to form water, and water is formed when the OH group comes from carboxylic acid and hydrogen comes from the alcohol. We done this thing in ester's agent. The esters bun rate even then water is formed, and the OH comes from carboxylic acid and hydrogen comes from alcohol. So this carboxylic acid OH goes, this alcohol hydrogen will go where polymer के end we show free. So ये वाला OH भी चला जाएगा. This hydrogen will also be gone. I mean, we just assume that there are more monomers on the sides, and they just react. So when this water is formed, this carbon will actually bond with this oxygen there. Because this carbon will have a free bond, this oxygen will have a free bond. I would say, yeah, atoms निकलेंगे. So when I show the product, as I said, we show the ends of the polymer free. We remove the OH group and write C double bond. Then we put this box. Then this oxygen. Now this link here is serial bond 2 link. This link is called ester link. Or ester bond. And because this may so many of these kind of bonds repeat throughout, that's why we call it polyester. That's like the structural form of the polyester. The thing is, the condensation polymer with the repeat unit is both monomers, right? Like first and second monomer together. This whole thing is the repeat unit. So ये जो column square bracket में लगा रहे हो, this is the repeat unit. Technically, addition polymer में I told you two carbon atoms, two consecutive carbon atoms make up the repeat unit. लेकिन condensation polymer में both the monomers would be counted as the repeat unit. तो ये पूरा जो मैंने bracket में लगाया है, that is the repeat unit. So how would you get the questions from this, by the way? जब आप लोगों ने इसको once you draw it, then I'll explain the questions format. And I might not be writing all these things, but you need to understand. What I've written on the board, you need to memorize it. Memorize as in, you need to know what are the physical properties of the polyester, and based on the physical properties of the polyester, where do we use it? And then you should know what are the monomers of polyester. You get to draw the monomers. When you get to draw the monomers of the polyester, तो उसमें आप functional group निकालेंगे serial bond OH, and in between you can put this box, and you could actually leave your box empty or shade it, right? दोनों तरह निकाल सकते हैं. You could actually make it oval shape or circular even. इस तरह oval shape भी बना सकते हैं. But whatever you draw, or if examiner gives you these monomers, you should know कि your box is CH2 group. It could be one CH2 here, it could be two CH2, three CH2, 4, 5 CH2, many number of CH2. So it's not fixed. Because the number of CH2 is not fixed here, you don't write it. ठीक है ना, इसलिए हम इसको लिखते नहीं हैं. अच्छा, अब हो सकता है कि इसकी जगह एग्जाम्पल आपको इस तरह से लिख के दे दें CH2 and बाहर write N. In any case, you don't need to be worried about what is written here. कोई शेप है या CH2 लिखा है कि नहीं लिखा. You need to know the reaction is happening on the sides. Function of the reaction. But they ask you what's indicated or what does this shaded box signify? Shows box and shows CH2 carbon chain inside. So दूसरी बात ये कि other than the monomers, typically you don't get to draw the structure of the polymer yourself. They give you the whole structure of the polymer in मिलता है and from this structure of the polymer, they want you to guess the polymer it is. And once you see these shapes, oval or square or whatever shapes dotted or clear, and then you have these ester linkages repeating like that, you should know the ester, polyester. Here they ask you what byproduct is formed in polymerization of polyester. The water is the byproduct, right? And then they ask you to mark or circle the ester linkage. This area here, serial bond O and O, that is the entire ester link. This is pure form ester linkage. The third, in very rare cases, you might get the monomers given and you might have to draw the polymer yourself. This you need to be able to draw the structure of the polymer from the monomers. That's the reaction. You need to know how. Second, they ask you to show on the monomers where water is lost from. I mean, with the box, show how water is lost. इस तरह से आप इसको box लगा के दिखाएंगे. A OH comes from carboxylic acid, and hydrogen comes from alcohol. ठीक है? समझ आया? बाकी वाले इसको याद करना है. I've seen students telling कि sir condensation polymers are difficult. याद नहीं होती. See, there is no shortcut to that. Condensation polymers, sorry details that I've told you, you need to memorize that and try and write it once or twice in rough notebook. Pick them up once you do it, then it will be okay for the exam. Otherwise, if you get scared from the size of the molecule given in question and you don't read the question first, Pehli, if you get scared, so then the question becomes difficult, obviously. अब ये सिलेबस में आपको करने हैं. ये जो पॉलिएस्टर है इसके कॉमन एग्जांपल जो मैं इधर लिख देता हूं. टेरेलिन is one common polyester. There are many polyester. There are hundreds of polyester used. और वो किस तरह से different है based on the number of carbon chain in the middle. One CH2, 2, 3, 4 different. So based on that, the polyester are different. Teriline is one common industrial polymer जो dresses और सारे garments में use होता है. So teriline is in your syllabus to be memorized. Remember as a condensation polyester. ठीक है? तो याद करना. ये MCQs में आता है. Which of the following is a condensation polymer? उसमें polythene, PVC, Teflon, or teriline वगैरह लिखा हुआ है. So rest of the polymers are addition polymers. This teriline is a condensation polymer, right? So let's do the polyamide also. Second condensation polymer जो आपके syllabus में लिखे हैं, that is polyamide. So polyester means many ester bonds, right? And polyamide means many amide bonds. Amide bond क्या होता है? Single bond O and nitrogen. यहाँ पर single bond O के बाद over here instead of oxygen we have nitrogen. That's called polyamide. A polyamide is strong or hard. And because of this property, this polyamide is used as ropes in industry and in domestic purposes to use as ropes or basically polyamide only is for nylon. Just like teriline is a common polyester polymer, nylon is the common term for polyamide. Like we say nylon ropes, nylon material, like these bags and picnic tents, umbrellas, they're all made from nylon, right? So used as ropes or making of tents, etc. That's all nylon material. When I say ropes, so the common ropes that you see available in the hardware store, different color ropes, nylon ropes, that is actually polyamide, but relatively not that strong one. We have different forms of polyamide which are used in industry and they're extremely strong. In fact, many of the polyamide types are stronger than steel cables. So, you know, these suspension bridges which are made by the suspension cables. Yeah, the cables. So, like that Golden Gate Bridge in Mecca, they made in 40s, I guess. So, that is like one of the famous suspension bridge. That the ropes which hold that bridge, they're steel ropes. Usme Golden Gate Bridge, the one that you see in movies also. But now in Korea, Japan, China, suspension bridges are made from polyamide ropes, polyamide cables, by the way. And these polyamide cables are many times, it's said 100 times stronger than steel cables. They are light in weight, they don't weigh much. Plastic, it's kind of plastic, right? Where it doesn't rust, plastic doesn't rust. That bridge, Golden Gate Bridge, I saw a documentary on that. It shows how they keep that bridge safe from rusting. So they technically use all the methods like galvanizing, painting, oil spray, and everything. And because the length of the bridge is so much that they start from one side, and by the time they reach the other end, it's almost the whole year. And then they start over again. So it's that bridge, for example, or any bridge which is made from steel cables, it is under the process of protection throughout the year. But if you use these polyamide cables, they are strong, much stronger, they don't rust, they're lightweight, they can be recycled. अब सारे suspension bridges are made from these cables. These helicopters, military helicopters that you see, which can lift up the whole tank, the cables they use are polyamide cables, not steel cables. In shipyard, mein, dry docks, the ships lift those containers and put them on the, cranes pick up those containers and put on the ships. They use polyamide cables. Extremely strong. So, अब इसके जो monomers हैं, वो भी लिखेंगे. Its monomer dicarboxylic acid. Polyamide के जो monomer है, that also is dicarboxylic acid. Just like that. It's like dicarboxylic acid and diamine. Diamine is like NH2 group. NH2 group. So the difference in the polyester and polyamide polymers, वहाँ पर we have diol and here we have diamine. कोई difference नहीं. Based on this, these monomers, if I draw the structure of this polyamide, reaction will exactly happen in the same way, same conditions. इसके लिए show this equation. So this dicarboxylic acid reacts with this diamine, or diamine को हम just draw open like NH2 के bonds ऐसे open कर, so that we can show exactly how reaction is happening. We concentrate sulfuric acid and heat is the required. Conditions हैं ये भी आपको याद रखनी. So could you guys guess where water would be lost from? In this case, it's the condensation polymer. So if I'm supposed to put a box where water is lost from, where should I put that box? So which from obviously carbonic acid and hydrogen, one of the hydrogen of the NH2. Yeah, we show them fluids. I mean, we show them removed. We show the ends of the polymer free because what we show is like reaction between two monomers. But naturally, it's not the two monomers, the thousands of monomers which are lying side by side and they're trying to react with each other. Right? So scale and some free dikhate hain. Now, when I draw the structure, it will actually start from there. See, I will go box. See, I will go niche. Box. Niche. Now, this linkage here, this is called mark link. So these two polymers are the ones which we really need to memorize well. The monomers, the uses, physical properties, the weight unit is the weight unit. This is the weight unit. उसके बाद जो मैंने natural condensation लिखे थे protein, DNA, carbohydrate. You don't need to know their structures in detail, but very briefly about carbohydrates. I'll explain tomorrow. So, your question here was, do you guys study after TAR also or not? Or just focus on eating?